Good afternoon, everyone. My name is Jason Grimm. I'm a consulting solutions architect at ZEDEDA in the office of the field CTO and VP of strategy. A few minutes on my background. I've been around a long time, like most of us in the industry. Went from Georgia Tech, recruited to do naval intelligence, deep background in security and networking. Went on to do some work for some three-letter agencies. So my career started, and I still am a deep networking and security person. I'm out of Atlanta. When I came back from Atlanta, I started a company called Freedom Link, which was a metro area wireless meshing platform, which I ran for 4 years. You probably recognize the brand today because it still exists. I got bought out / forced out by Southwest Bell. After that, I went to Dell for about 9 years for consulting. I got into HPC, and at that time, HPC was really the predecessor to cloud, infrastructure as code, hyperscale, all that stuff. I went into cloud in 2012 when it was called a specialty versus the commodity that it is now. OpenStack, got to do some cool stuff at CERN for the LHC, went on to Cisco, continued to do private and public cloud, OpenStack, AWS, Azure, GCP, Cisco to AWS, full-time as an architect, and now presently at ZEDEDA, where my job is to talk to customers and educate them on what's going on in the market, solve those problems for them. And what ZEDEDA does, cloud is not about where you run, it's about how you run. It's an operating model. So our vision, and we've been doing this going on 8 years, we kind of pioneered in this space, is taking, you're kind of seeing a consistent theme here, we're taking that cloud operating model and pushing it all the way to the edge, where we have those problems that we've been mentioning all along about environmental and hands-on. So today I'm very excited to talk with you about one of our customers in the rail industry. And without further ado, I'll get started. So 20,000 plus. I'm going to come back to that number. Just think about that number and where we'll come back around to it. So one of our Class 1 railroad customers, they own and operate 8,000 locomotives. They're a very large organization. They ship 535 million tons of freight annually. And they're transporting that across 28 states. So this is a picture of what's called a hotbox in the industry. It is a detector that is sensing heat on the wheels and looking for distress there. The hot wheels are the #1 cause of derailments. We've seen the news. These are bad. We don't want them to happen. And this customer has 4,000 of these hotbox detectors deployed today. Now those are deployed across 32,000 miles of track. This is where it's talking about these remote location, no IT. This is the -40 to plus 160 degrees Fahrenheit. So it's this embedded industrial technology. How do you do cloud stuff with those kinds of devices and those kinds of conditions? Like some of the other use cases we talked about, it's a highly regulated industry. They want to prevent, obviously, derailings. Those are bad for everybody, certainly their business. And so this new regulatory environment is going to increase their number of nodes by 5x for the edge devices. So that 20,000 node they're going to have to go from 4,000 to 20,000 detectors. And they all.
So Jason, so those detectors are located somewhere on the tracks. As the train goes by, it actually detects the temperature of every single wheel as it goes past. Is that correct?
Correct. Okay. Yes. Now and we'll talk about some of the new technology and use cases. The hot boxes that are in today are some of the detectors that also they're going from 20 to 50 miles, depending on whether it's metro or rural, to 10 to 25 miles. So that's just a doubling there. But the regulation also encourages and will eventually be required that they advance the capabilities there with computer vision and AI inference locally at the edge to do more things than just detect heat, because there's more problems than just that cause railway accidents, right? And we'll get into that a little bit. But that's the 20,000 number. This is like some of the other use cases we talked about. This is a business killer. If you can't scale, if you can't do this, you can't meet these regulations, you don't work. Your business suffers or doesn't exist anymore. So it is a thing that absolutely has to be done, and this is what we're partnering with them to do, is build the mechanisms that we talked about for the distributed deployment and management of all these nodes in the software. So, any other questions? Okay, so what are the customer technical challenges? Scale, scale, scale. You'll hear us talk about this. This is one of our key sweet spots, is to do this stuff at 5 and 10 and 20,000 nodes. It is very difficult to build and manage those fleets individually, right? So security, another common thread that you're going to see throughout. We've got physical security. These are pictures of bungalows. Anybody can walk in and break the door. Well, there's hot boxes they can just pick up and walk away with. So you have a physical security issue. You have to assume that it's an untrusted device and that it's going to be, if someone does walk off with it, it is going to be bricked. But you've got digital security concerns as well. Anyone plugging something into the device. Let me move this a little bit. Boy, there we go. These are in remote, unsecured areas. They're not monitored. That you don't know if someone's plugging something into a device. We have to be able to, or they have to be able to detect all of that intrusion, physical or otherwise. Connectivity. So you might have 2G, 4G, 5G cable, PTSN, satellite, microwave. So these bungalows may have a diverse amount of connectivity. You don't know what that connectivity is going to be. How many devices do they have to put in the bungalow? How many custom models and makes do they have to create so that they can have connectivity everywhere? And how do you manage that, right? And satellite as well. So again, remote and hard access locations. I mentioned minus 60 to plus 150. What hardware profile fits in that, and operations and the total cost of ownership. So no local IT staff. How do you put, they're going from 4,000 to 20,000. How do you put 16,000 nodes in a box, someone walking out, plugging it in, installing something? You saw in an earlier demo, the user experience is they get someone at the rail side gets a box, they take the device out of the box, they plug it in, it connects over the diverse connectivity that's available, and then it gets its config pushed down to it and all the apps that are pushed down to it. And these apps are going to be the things like the AI inference, running along SD-WAN, running alongside a firewall, running along some streaming application to stream the data back, and have the GPUs and CPUs in the box to do that local inference, because that stuff has to be done real time. Shipping it back to cloud might be too late, or it's cost ineffective, or so all of that stuff has to be done locally, and that's what I mean by we're pushing all of the infrastructure as code, all of the app marketplace, all the eventual consistency, all the statelessness, all of that to the edge. That's what we're kind of built to do. So, any questions before I move on?
Are you pushing down things to hot boxes themselves, or are those just sort of sensors of some type going to a box that's nearby?
The hot boxes are fairly unsophisticated in terms of what the new computer vision tech is going to be. So we're getting an I/O stream of sensor data off of that box, and we're going to be receiving that and doing some analysis and doing some alertings from that. They have a system today, but we are replacing multiple units there to make that more efficient and manage that at scale. Now, yeah.
So how many sensors then are you saying for each of those little white huts on the side there that collect the information? Because that's why you're saying you're pushing down to
Right.
the thing beside the track, right?
Right.
And you have the sensors reporting to them. Is that correct?
Yes. Manny might jump in here because he was help
Yeah.
one of his customers. Yeah. But go ahead.
Yeah, so the existing sensors is 4,000, okay? And then they're from heat sensors to avalanche sensors to acoustic. And through the legislation that's been passed, now they have to increase the frequency of where they position these sensors. And that's what's triggered the railroad company to start deploying more of these sensors. And they're going to leverage our platform to provide the connectivity applications, a little bit of a different use case at the edge to provide the WAN connectivity for those sensors that are on site in those bungalows and kiosks. So we'll be orchestrating an application that is going to provide their WAN connectivity.
And that's to that little bungalow, whatever
Correct.
you call it, right? So it's just not to 20,000
It's
sensors.
it's basically an SD-WAN that they're going to be deploying there
And
to provide
And
the
how many of those are we talking about?
doubling of that 4,000, about 8,000.
No, you're talking.
I had the
How
number.
many sensors? I'm getting a little confused. How many bungalows and how many sensors?
Well, the
You're not
sensors,
managing
the
the
sensors
sensors,
is
right?
4,000. Those are going to double. The bungalows are positioned close to the sensors, so they might share a few.
We
Right.
had a number. It's over 10,000 of these rail sites. I don't have the number at the top of my head, but we can come back.
Yeah,
to
it's
it.
not a per sensor bungalow. There is a consolidation between
Okay.
1 to 4.
Okay, so how at ZEDEDA do we solve these kinds of problems for our customer, right? One of them is scale. We've got a proven model. We've been around for 8 years building this stuff. We're running 17,000 nodes in a single environment that's going to scale to 70,000. So we're built for scale out of the box, and that's a lot of this problem is running the 20,000 nodes. And then again, we talked a lot about zero trust and the measured boot and the PCR hashes, and so the product is built to be intrinsically secure. There is measures in place where you cannot plug in a USB stick will change the timing of the measured boot and force a failback to a partition or put the device in a suspect state. So this encryption at rest, encryption in flight, read-only root file system, it is built from the ground up to be secure. You certainly don't want anyone at the rail side plugging anything in and doing any kind of man-in-the-middle activity, right? So that's all. The connectivity, I have a diagram here in a minute, and it shows, cable, fiber, PTSN, microwave, satellite, everything in between. So how, as code, as a device, do you plug something in and say, okay, I've got configs, the policy is applied, and it's like, oh, I know that this is this kind of site, or these ports are detected, and here's my primary route, and here's my backup route, and here's multipath, and here's FortiGate, and how I'm connecting to the SD-WAN. I mean, that's kind of like magic. I mean, it is a lot of complexity. It is a lot of things where customers are trying to do this by hand. They may have half a dozen devices, and they've got half a dozen management tools, and they've got, where do you manage state? Where do you manage updates? All those applications. So the connectivity is huge. It's almost in every one of our customer profiles is that we're providing some form of connectivity and firewall.
Question on the connectivity piece. This is just more of a curiosity.
Mhm.
Is anybody doing, we tried this years ago, moving any data to the passing locomotive because it's such a remote location, moving it to and from the locomotive as it goes by? I'm just wondering.
That's a very good question. I don't know that personally. I would love to take that offline. I did see something very cool the other day in another rail customer that we're talking with, where they're building tunnels. The locomotives are going through at 70 miles an hour,
Right.
which they're doing here too. But that implies that there is some data going back and forth to the locomotives, like some things that can be changed without a locomotive is operating, which I think is very cool. I mean, that's the edge. It's overloaded term, right? That's the edge of where we're going. I think is that kind of real time feeding that data back to make adjustments to the locomotive. I would love to come back around to that. I don't have an answer for you though. Environment. So we talked about security, zero touch, the problem of scale. I know we keep coming back to it, but it is what blocks our customers, right? There's no local IT staff. We take it out of the box, we plug it in. Manny's going to come up in a minute and finish the demo and show how that works. And this came on. It does need power. It does need to be turned on. We realize that, and that was what was wrong before, but it is on now, and it is registered. So we haven't figured out how to get around power. So remotely manage and operate policy engine, create a desired state, it inherits that state. If it dies, you plug in another one, it inherits a state. It is a zero touch. If you had all the money you wanted, sure, you can go and touch those things, but it's just not, it's a business killer. It's not possible to scale like this with putting hands on boxes or anything like that. So, okay, so here's the architecture. This is kind of, it doesn't show the hotbox in this one, although in reality, that camera would be multiple sensors. You're going to have the acoustics, you're going to have the heat. The camera was just kind of the coolest one. That's where everything's AI. That's where inference is going. This is where computer vision is going. So the train's barreling down the track. The camera is gathering data in the terms of photo streams across the track. It is pushing that into our device or devices. We might have one or two devices for a failover scenario. This is a picture of Eve. This is where this is where the edge virtualization engine software is running. It is all of the A/B partitioning and things that we talked about. There's the trusted platform for authentication, and the GPU is streaming that to the AI and OS apps running on top. So that real-time inference is happening here in Eve. These are the diverse connectivity methods that I mentioned. So it's egressing out of this local bungalow with this real-time data. The applications are going to make some local decisions and inference. That's what we're working on now. And then, but it's going to go up to the customer in the ZEDEDA NOCs. So we didn't talk a lot about the support model around all of this. Like we have a NOC we're looking at in real time, especially for our production customers. We're looking at variations in their environment. We're looking for, this is the ZEDEDA Cloud Controller SaaS is for deployment management, but it also has a rich interface and an open API for all of your logging, all of your monitoring, all of your alerts, all of the states, all of that is there. Our customer NOC has access to that. We have access to that. So we're wrapping a model of support around all of that operational details so that we can see things that are, suspect state or loss of connectivity, and we can take actions from that. I think that, okay, yeah, so we talked about what's next. So computer vision for wheel defect monitoring. So some of these are with the other, some of our other rail providers. So railroad crossing safety. People run the tracks, they try and beat the train. Not a great idea sometimes, right? Does not end well often. So this one is kind of fun, the tractor trailer logistics and payload tracking. So we go into a smart parking lot and it's like, show me which lot is open and show me where my car is and all that stuff. Well, I didn't have a picture of the rail yards, but there are thousands of containers and locomotives sitting around, and they're not always where they're supposed to be. So what do you do when you go to pick up a piece of cargo? The train's leaving, by the way. You don't know where your thing is. So some kind of a known pattern for visualization is to do that tracking, right? Kind of a low tech use case, just like the parking lots, but it is a really big problem. It affects business. It affects all the things, right? Trespassing and rail trail prevention, people walking along the tracks up to no good or up to harm themselves or somebody else. Certainly not good for the people and certainly not good for the operator. And advanced traffic control. So these are, you'll see a pattern, these old kind of legacy analog systems, we're bringing them up, we're containerizing them, we're making them more efficient, we're making them more available, making the data more accessible. And, in this case, looking at traffic and route optimization, because, again, we can bring AI, we can do real-time inference and visualization of what's going on versus what they think is going on in terms of where things are.
Jason, can I jump in on a comment here?
Please, yeah.
So we talk about these what's next pieces, and it's less maybe important what they're doing next, but more along the lines that by using our solution, they can change it over time. These devices live 10 years in the field. In most cases, they'll buy a piece of hardware and they'll park it there for 10 years. Software changes a lot in 10 years. So they're bringing in new applications, they're bringing in new use cases, they're bringing in security patches. Often they're replatforming applications, so they'll start in a virtual machine and end up in a container a year or two later. So we give them that flexibility through, a few clicks or a couple API hits to update these thousands of sites with new apps or changes to the apps. So we tried to capture some of that in the what's next. So maybe think of it at that level than the specifics, but here's some of the use cases they're driving to those devices.
Yep. I like the replatforming comment, right?
Yeah.
Because the traffic control has long existed on mainframes back at some central data center, right? And you're kind of giving them a new path to how I'm collecting and then giving that data back to said mainframe, right?
Absolutely.
Or pushing out some of those server/serviceless applications from the mainframe out to the edge, right?
Yeah.
Because that's where the central control is happening, is some big box somewhere.
Yeah, and this is a big change. I mean, it's not just for railroads. You think about the number of Cisco appliances or Juniper appliances that single function, thousands and thousands of places. Like being able to run applications next to that and change those over time really lifts that up a lot. So we see a trend of people kind of getting rid of these single-use appliances, doing more and more on a commodity server like this, bringing workloads in over time, modernizing, et cetera. So we give them a nice platform that allows them to do that over time.
Yes. So this will be posted publicly. If you want to learn more, go to this link and you can find the GitHub repo with the Terraform code, all of the stuff here, getting started, create a free account, and all that. Thank you for your time and attention today. I really appreciate the opportunity to speak with you. And we went through questions.
So,
and cut.
What you're doing, sorry.
No, go ahead.
What you guys are doing at the edge. So the last example, not so much. That's very much so seems like a transient, stateless type of application. But the dealership model that you're talking about, where you're taking legacy applications that were there and present, and then you're converting them to VMs, and then at some point you're taking that next step to containerizing and all that kind of stuff. That feels like a very much so a stateful application, that the things that are living there at the edge, they're storing and living, they have long-term data on them. Is that a pretty correct statement?
In certain use cases, yes. In certain use cases, no. Now, the automobile dealership example is kind of a little bit of both, in that part of the regulation coming out of the EU is you have to protect that image. It can make your car go, stop, turn, right? It's like protected software. You also have to delete it, and you have to prove you deleted it after you flash the car. So it's stateful in a period of time and then deleted out.
Right, but I mean, like your inventory systems and stuff like that, that you're talking about what's next, that's stateful, which all of this is leading to say, do you have something in your platform that takes care of the actual data protection and, resiliency of those systems that are there for the stateful data parts? Or is it based on the whole stateless mindset around containerization?
I mean, I'll let him answer the technical question. The short question is, like,
back it up?
We could back it up. Back it up and restore it. We can, if we have multiple nodes on site, then there's different techniques we can use. Most often, as I mentioned, we tend to be single node solutions because you're going to 20,000 railroad locations, and they tend to use a backup and restore mechanism for that.
Okay, but in the upstream application, right? Once it goes up to the cloud, you're not backing it up.
There's nowhere to back it up locally, correct? Yeah.
Right.
So you're backing it.
On the edge, we do support things like snapshots. So you can do certain types of backups there.
Okay.
Yeah.